In Assignment 5, in the course Simulations in Tribology at Luleå University of Technology, the student is supposed to model a cylindrical step bearing by means of the finite element method. This will be done by using the software console multiphysics. The multiphysics in this case refers to the fluid structure interaction that is caused by the hydrodynamic pressure build-up over the bearing segments. In COMSOL, a model will be built that is based on the structural mechanics physics. This physics lets you model the elastic slab of material that in this case will be representing the bearing collar. In the structural mechanics physics, it is the displacement field which is the dependent variables. W, which is the displacement normal to the bearing pad surface, will alter the gap between the bearing and the collar. The gap between the bearing and the collar is known as the film thickness when modeling the thin film flow in this interface by means of the Reynolds equation. In reality, it is the collar that drags the lubricant in over the fixed bearing surface. When you model stationary thin film flow by means of the Reynolds equation, it is only the average speed of the surfaces that counts, and either one of the surfaces can thus be thought of as moving. In the description of the assignment, you will find an explicit expression for the Reynolds equation, which represents a stationary, Newtonian, and incompressible flow. It is stated in Cartesian coordinates. You will also find the expression for the velocity, in this case representing rotation by means of an angular velocity omega. When you scrutinize this expression, you will find that it represents counterclockwise rotation. Moreover, you will find an explicit expression for the bearing pad, which is a cylindrical segment exhibiting a step which creates the convergent gap required for pressure buildup. This step is located at the angle theta s, and the angular size of the bearing pad is theta p. The step height is delta h, and the trailing edge film thickness is h naught.